Okay, hi everyone, I'm Adam Brown, I'm the UK manager for Quotium Technologies and also the technical guy. What I'm going to talk to you about for the next 10 minutes is data-centric application security, which really means how do you x-ray your web applications to find those bugs in real working systems. So the reason that I'm here, the reason that Quotium's here, and the reason that we have our solution is because applications are weak. They're the weak link in the security chain. We know that because of the press. I mean, 2011 was the year of the hack, and if you actually analyse some of those press cuttings and see what's behind a lot of the vulnerabilities, it tends to be the application or a weak application. For example, Citibank. Last year confirmed a hacking attack. If you look down into that, it was a parameter tampering vulnerability. SQL injection seems to be 97% of data breaches, and Barclays are calling for better information security management. And just last month, Tumblr users should be aware of cookie thieves. That's a cross-site scripting vulnerability inside the Tumblr application. One guy said, I could get the cookies of any user who visits my profile page. So that means, of course, if you're already in your banking portal and you're going to Tumblr, then that means he's potentially got access to your banking details and so on. Just some numbers, 75%, according to Gartner, of all attacks on web applications or on websites target the actual application itself. So these hackers aren't really motivated so much anymore to go for the network layer. It's really the soft spot is the application, and they know that. 75 is also the number of vulnerabilities per year per website. That's from White Hat's report last month. So the number is going down, but it's still quite a lot of vulnerabilities in one website. And 92% of vulnerabilities are in applications and not in the networks. That's according to the National Institute of Standards and Technology. So this is all information I've got from research. And 99% of web applications are not compliant with the PCI DSS standard requirements, according to the Web Application Security Consortium. Just at the bottom there, I've got a quick infographic which shows, this is also from NIST actually, the distribution of vulnerabilities across the technology. So blue is server applications, red is non-server applications, and green is operating systems. The rest is hardware, communications networks, and other points. So you can see it seems that applications and software is really the weak point. So why is that? Well, it seems that current solutions aren't really delivering for application security. It's really in its infancy. So while networks for the last couple of decades have been pretty well understood and pretty well firmed up, the technology for application security, it seems not to be delivering. So I'm categorizing this into two types really. DAS, Dynamic Application Security Testing, scanning, black box testing. You could also call a web application firewall or a web application gateway it would fall into the DAS camp. So these are scanners, black box testers. So you have no visibility on the inside of the application. You're pushing in hundreds of thousands of attacks and hoping to get something back. The unfortunate point is it doesn't have a great coverage of all the vulnerabilities that we know are exploitable. So you get a lot of false negatives. On top of that, they create an awful lot of noise, a huge amount of noise. You get a huge amount of false positives from this type of technology. So the other approach is static application security testing. So this is really something for early on in the development lifecycle and something for developers to use. The issue is you do have to know your code really well to understand what these things are telling you. That's a pretty rare skill. And if you take, I saw a review recently where it showed less than 1 in 100 developers have ever had any kind of security training. It's unlikely to find that kind of skill. So these are also white box tools and static analyzers. So we have a raft of vulnerabilities not being detected. So what about an advanced penetration test? So we're talking about some of the really good guys in application security. Why is that an unsatisfactory solution? Because it's not for everybody. There's not enough of these people about. This thing needs to be automated. There needs to be an automatic way to do an advanced penetration test, to find these exotic vulnerabilities, to find, but without false positives. Until now, so this isn't my pitch, of course, we have Seeker, which is a real solution that addresses real risk for the business. So I would say that, but Gartner also said in their report in April, Quotium brings all of this together. It tests an attack starting with data input into application interfaces through the code execution and down to the database access and database manipulation. The only existing alternative to this technology is a manual penetration testing approach, a highly expensive and non-scalable approach. So Seeker enables you to create secure software, because we've heard this morning about AETs and APTs. The thing is, it's if you look at the thing like a lobster, a crustacean, to make the outside really hard is not really effective, because you've got the weak flesh in the inside, which is the application. So we're talking about making the application hard through secure software. So that is a very complicated process, and really what we need to do is find a way to do that effectively and efficiently. So Seeker does that with no false positives, so development of something real to concentrate on, something concrete. Fewer false negatives, we have much broader coverage. We show root cause analysis, so we go down, I'm saying two important things here, 0 false positives, and we go down to show the source code, which is relating to the vulnerability, and we do that without having the source code. So I have another slide that fills you in on that later on. So we focus on real vulnerabilities, and therefore you have less post facto vulnerabilities. So you reduce the cost and time of the development cycle. So Seeker reduces the cost and detection of correction of application vulnerabilities and compromising business data. Seeker is designed for not only security professionals, but what it produces in terms of its reports, its output, needs to be understandable by non-security people. We want QA people using this, we want developers using this. And so everybody becomes implicit in security, developing a secure application. So we enable secure software even in third-party applications, even if you don't have the source code. If you look at our website, you'll see that we found vulnerabilities in SharePoint, and that's published on Microsoft. So I did say no false positives, and I did say that we link to source code without the source, and we do that. I'm just going to show you this graphic. I'm not going to explain too much, but what you'll see is we trace, this is the data-centric approach, so we trace the data through the application stack. So we'll see something that's entered at the front end, and we'll see if it will actually be executed on the database, to take a SQL injection example. What I'm going to do now is show you, I've only got 2 minutes, so I'm going to show you as quickly as I can a quick demo of the application. We have here some results. Does this mouse work? No. On the top left, this is a branch search page, and it's red because it has a critical vulnerability. So there it is, we have a description, it's SQL injection. It's very critical because it's available to unauthenticated users, and we can actually execute union select. So what's that mean? Well, the next step is to go to a video. And what the video is an actual attack on the target application. So if you have Seeker, and we're going to show you a video, it's not going to be a generic video, it's going to be a video of the attack that Seeker made on your application. So I'm now going to try switch to the video. Yeah, if you would please. Great. Okay, thank you. So this is a normal use case. Branch code 100, it comes back with the branch details in a branch search screen. The next thing Seeker's going to do is show you the successful attacks it made. So it did a SQL injection probe, we got a server error back, some kind of database error. Okay, great. Not so interesting. The next thing is to perform a working SQL injection statement. So we're putting in a double hyphen, we know it's a SQL server because of the technology we're running at the back end. Now we're going to do a union select to see if we can find SQL injection working and running on the SQL server in this case. And yes, we did. We got the thing to execute, and the string that we sent is reflected on the screen. The next thing is actual data theft. So we're going to try and steal a list of table names from a list of database tables, and on the find branch screen you have some pretty important database information on there, which is just system tables, but that could, of course, be balance information, pretty sensitive information. Okay, great, yeah. So the next step, so you're not going to be the developer's best friend right now until you show them this. You move across to the technical details and say, hey, look, Mr. Developer, you need to be looking at this DLL, and this function, and this is the source code. But we don't even have the source code, so how have we done that? Well, if you look, it actually says pseudo source code. We reverse engineer the binaries that are running on the application server, or in the case of a database, we'll take store procedures and show a pseudo version of that code. And finally, this is really useful to developers who don't really understand security. We'd say, well, look, guys, this is a tip. These are some tips on how to eradicate this issue. So how to create code with secure parameterized queries. And then finally, there you go. Thank you.